Okay, so at this point, you've seen me do up to example 7 with inscribed angles. So let's try this one that has the diagram look a little messier. And then you can, right, when it looks a little messier, right, what do? You do the same thing. You trace your angles and you don't get overwhelmed by the problem. So how about I trace this angle right here? Okay, using one color, and it opens up to this arc. So what do I know? Inscribed angle. Right? See that, and you simply say, do I use the 65 or the 60? Which angle did I just trace? I just traced the 65, so I'm going to double it. That's going to be 130. Okay, so get that. Okay. Now let's trace the 60 and see what happens when I trace the 60. And trace the 60, it opens up to this arc right here. Okay, again, the inscribed angles half the arc that it subtends or intersects. So I'm going to double it to get 120. So the measure of the arc of the measure of the angle of the arc of ON is 120 degrees. Okay, what's left over? We have to get angle NOM. Oh, angle NOM. That's going to be, I'm using lots of colors here, that's this angle right here. Okay, which opens up to this arc right here. Now you can see I don't have either of those measurements at the beginning, right? But if I look back at the diagram, there's a couple things I could use, and it's up to you which one you see. I see that I could use the circle, that 1, 2, 3, they add up to 360, right? Or I could use the triangle, 1, 2, 3, in that triangle, add up to 180. Either way, it doesn't really matter, right? It's really a personal preference. I'm going to go to the outside here, because I feel like I can see it better. So 120 and 130 together are 250. And I'm going to take it away from 360. So that tells me that this must be 110 degrees. That's all that's left there. Okay. And if I say, oh, there's my arc, and that arc is traced in black, right? What's the angle that's traced in black? It's half of that, so it's going to be 55. And I can be confident in that answer because if I look at the triangle, those angles do in fact add up to 180 degrees. I get 110 there. Okay? So use that similar strategy to help you to complete example 9 there. Right? Trace each of the angles. Do your best as it breaks up. Right? And in this one's a little different because you're going to have pieces that add up to give you the angles. So just trace the angles, and you might have to do a little bit of additional work there, but you can do that. Okay? Last thing for angles. Right. Oops, let me get it on the screen. Okay, there we go. Alright, so other angles. There's one other angle in the circle that we're going to deal with. Okay? Okay, if you take a circle and you put a tangent to it, remember tangent just intersects at one point, and if I draw the radius in, okay, Right, there's this last circle. This is the angle we're talking about. I'll highlight that. Right, the angle between the tangent and the radius. Okay, and it's good to know going forward. We use this when I teach trig. We use this a lot. Right, that this angle right here is always measures 90 degrees. Okay, every single time. Every single time, right? They're always going to be perpendicular. Okay, so it's good to know, right, that a tangent to a circle is perpendicular to the radius. Okay, and it's as long as, I mean, we're talking the radius that has that goes through that point right there. Right, so okay, so. Okay, so for this one, find the indicated measure in each diagram, given that the tangent and radius of the circle are shown in the diagram, shown for the circle. Okay, so that's the tangent right there. That's the radius. So I'll put in what I just showed you, and that's a right angle. So it's a 90-degree angle. Okay. Okay. So we need to find this length right here. Worth noting now is that if I were to trace this is how this is really going to help me. I can see that it forms a right triangle for myself. Okay, see that right triangle there? And sometimes the right triangle is going to be with the diameter, and sometimes it's going to be with the radius. You don't know which one. You just kind of, but there is going to be a right triangle because of that tangent being perpendicular to the radius. Okay, so if I look at that, I can see I have 15 as the hypotenuse. I have 9 as one of the legs. Right? I'll get, this will be my length there. So it's 225 equals 81 plus b squared. B squared equals, I subtract 81. That's going to give me 144. So b is going to be 12. So this whole length is 12. Okay. Now, if it's a triple, that's a triple. Maybe you could have done without the Pythagorean theorem. Go for it. Good. Use that. Right? You don't have to do it for every single one. Okay, but that's 12. Okay, so if that whole thing's 12, well, that's the diameter. So since we have the diameter, that means this question mark, which is the radius, is going to be 6 because it's half as much. So we got 6 there. Okay. And B is the exact same type of problem. Notice that with C, right? You know, when you're doing this one, I'll do this one, okay, for you. Right? Here's my right angle. Okay. There's my right triangle. Okay. Maybe you recognize, hey, it's a triple for yourself, and you can do that pretty quickly, right? If you did, that's great. Otherwise, do the Pythagorean theorem, and you get that this is 15. Okay? Well, if we know that's 15, now we figure out this length. Okay? Remember that 9 is the radius, so this piece right here is 9, because a radius is a radius. It's always the same length. Okay? So this part's a radius there. Okay? And that's because that was 9. So if this was 8, that would have been 8. If I know this whole thing is 15, and that piece is 9, that means this left over right here is 6, and that's my answer. So we got the same answer for both those. 6 for both. Okay? And you should try B on your own. Okay, let me do this big example right here. Or let's get you started. Okay? Alright? You can do it on your own. You might want to pause it and try it and then check your answers. Alright? But let me just help you out with it in case you're kind of have some trouble. Find the measure of each angle and arc given that measure of angle BAC is 100 degrees. I'll put that in there. Okay? Okay, so let's see what we can do. Well, first thing I see is if that's 100, this is going to be 80 over there. So I'll fill that in. Okay? If I trace my angle, I can see this angle opens up to this arc. Okay, question, is it an inscribed angle or is it a central angle? Okay, well, it's a central angle. Central angles equal the arc, so that's 80. Okay? I see that this angle right here is 80 degrees. 80 degrees opens up to this arc right here, so that arc is 80 degrees. Okay? So I'm on my way. I can start to fill in some measurements. Let's see what we can put in there. Okay? So let's see. Measure of angle ACD. Oh, that's between the tangent and the radius, so that's 90 degrees no matter what. Okay, so let me put that 90 degrees there. Okay? Let's see. ABD. Right, angle ABD. Oh, that's also between a tangent and a radius, so that's also 90 degrees. Right on. CAE. CAE is right here. Oh, we just have that as 80, so I'll just fill it in. Measure angle BDC. Okay, so we have this one. Okay, so now I'm looking at like, how am I going to figure that out? That's a new type of angle. But, guys, remember, we've done so much this year. Use what we have already. Okay? If I take a look at it and I highlight it, okay? Right, that right there, that's a four-sided figure. Okay, quadrilateral. So I know that this quad is an angle sum, an interior angle sum of 360 from what we did in the first half of the year. Okay, that's 100. That's 90. That's 90. Add all that up, I get 100 plus 90 is 190 plus another 9 is 280. If I do 360 minus the 280 I already have, that means the last angle has to be 80 degrees. Okay, so this angle up here is 80 degrees. So that didn't even involve circles. We're just, because we have these angles from the past, we're going to use that. Just like when you try example 12, we're going to have parallel lines. You're going to use alternate interior angles to help you do that. You're going to use quadrilaterals. You're going to use triangles. You're going to use all this. Okay, it's a great review problem. Okay, let's see, measure of the angle for arc BE. So B to E is there, and it doesn't matter which way we go. It's a semicircle, so it's going to be 180 degrees. let's see, measure of the angle for the arc BC. Oh, we have that. That's 100 already. And the measure for the arc EBC. So E to B to C. Okay, I could do it two ways. All right, I could think about like, hey, this is 80, and that's the only part not included. So I could do 360 minus 80, which gives me 280 left over. Okay, so since that's the only part not included, you just subtract it away. Another way to do it is to say if I'm going from E to B to C, I have 180 here plus 100 there, so 180 plus 100 gives me the 280. It's all like up to you. It's personal preference for those types of problems. Okay, so now that you've seen all these examples, try the rest of them and then check your answers with the online notes and submit it for me. Thank you.